Okay, hello class. We're going to be looking over properties of logarithms. We were just introduced to the idea of a logarithm in the previous lesson. Now we're going to learn about some properties that are associated with it. I'm going to skip over some of the proof part and then just kind of go right into the properties right now. So when we talk about properties of logarithms, there are three of them that are critical to know. When we have a log of a number, and that number is a product, we can actually split it up into a sum of two other logs. And we should, as we learn these properties, we should be fluent in going in either direction. Either we take this single log and break it into two logs, a sum of two logs, or we can take a sum of two logs and condense it into a single log. So if I have the log of 35, which is made of 7 times 5, I could actually write it as log of 7 plus the log of 5. Now we're assuming here that the bases are all the same here. So, in all these cases, you notice that the bases are all the same for the expressions. When we have division here of the input of the log, we can break that up into two logs that are one subtracted by the other. So we have log of m divided by n is equal to the log of m minus the log of m minus the log of n. And last one is the exponent property. When we have an kind of a power inside, we can actually take this little n and pull it to the outside as such. So here's kind of a visual of how it looks. 35 is 7 times 5. So we can break that up into the sum of two logs. 8 is 16 divided by 2, so we can break that up into the difference of two logs. And here we have a power 10 to the third. We can bring this exponent out and multiply the exponent times log of the base. So these are the three important properties. Give these problems a try, and I'll show you the answers in 3, 2, 1. Now this last one here was a little trick, or not a trick I should say, but even though you were given two specific log values, there are two other ones that you should always know, even if they're not given to you. Log base 6 of 6 is always equal to 1, so, and also log base 6 of 1 is always equal to 0. So log base of the base is always 1. Log base of 1 is always 0. So you can use that as well in your arithmetic. So you have log base of 6 over 8, which is 0.75. We could turn that into the difference of two logs and then get our answer. Okay, that was an exercise using numbers. Now we're going to do the same exact thing, but we're going to use some variable terms, some expressions. So we can expand and we can condense. So whenever you see, a single term inside the log and it's just being multiplied with some powers, we can break that up into a sum and difference of various logs. So let's just start off. We see 5 times everything else, so that's log 5. Then we see this x squared term right there. That's being multiplied by the other pieces, so that's going to be the sum of another log, x squared. Then we have another multiplicative term right here, y to the 4th, so we break that up into another log, log to the 6th. And then on the denominator we have z to the 3rd power, so we subtract away log z to the 3rd. Okay, now we can use our exponent properties to kind of pull out the exponent from each one of these and multiply it in front of the log itself. So this one becomes the 2 here comes to the outside, 2 times the log of x, and the other ones are the same way. So we can take the same type of idea and go the other direction. So you should be very comfortable whenever you see a single log. Think about whether or not breaking it up helps. When you see a bunch of logs being added or subtracted, think about whether condensing it will help you. Okay, so we have, in this case here, I'm going to first do the sum and difference of the different logs. So I have log of, first I'm going to actually take this 4 and bring it up into the exponent here. So that's the first thing I do. Now I'm going to deal with the addition and subtraction of the logs. So I have log of x, or natural log of x, plus natural log of y to the 4th. So I'm going to multiply the x times the y to the 4th. Then I have this subtractive term, minus log of 3, natural log of 3, so I'll subtract, or divide there by 3. And there you go. We've condensed it into a single log. Again, a single log can be sometimes expanded into sum of multiple logs. We could have the sum difference of multiple logs condensed into a single log. So give that a try on these problems, and again, in 3, 2, 1, I will show the answers. Okay. Last thing in this lesson, change of base formula. This is a different, I don't call it a property, but it's something useful because in the calculator, we do not typically have a log base 3 button or a log base 7 button or whatever the log base might be. We typically only have log base 10 and log to the natural base of e. So we can actually calculate any log to any base. Say this one is generically having a base of y. We can actually calculate that on a calculator using this formula where the log to whatever base we want of x divided by the log to that same base of y. So you notice here, I just take this x, kind of bring it there, take the y, bring it down there, and I choose whatever base is convenient to me. Typically, you choose a common log or you choose the natural log because those are the buttons that exist on your calculator. So go ahead and, okay, here's an example. Log base 3 of 8. I can think of that as the log of 8 divided by the log of 3. That's my common log. Or natural log of 8 divided by natural log of 3. Either one works just fine. You get the same exact answer. So give the last 3 a try. That's the end of the lesson.